to show you the basic concept behind the processing stroke analysis of the multi-channel analysis of surface waves data. That's your MASW data. So I would also try to explain how the general seismic interpretation would occur, both your MASW and your seismic refraction. So you're going to do both of them. Try to marry them together. So from it, we can estimate elastic properties or elastic parameters, such as the Young modulus, Poisson's ratio, and as well as the density and so on. So all of these parameters can be useful in inferring the geotechnical properties of the site. Apart from that, also, I've spoken to a friend of mine, and she has been able to get for us a borehole log for a place close to Prayer Estate. So because this is a client's data, she cannot share the exact location. She just gave a general broad description. So what I will do is to share that with you later on to see if it would tally basically with our data sets, especially in the absence of no borehole data around that area. So I hope that would also work. So I'll start sharing my screen now. I will share all my screen. I believe you should be able to see my screen now. So this is your data set, and this is your data set. So these are the parameters that you used for your acquisition. And these parameters that you used, especially for the passive, is also not so good. I wonder why he used a sampling interval of 250 here and a number of samples of 4096. This is totally a reverse order, but we can still manage that. But for the passive, the time taken for the what's it called, the number of samples taken is pretty low. So that will give us challenge. In fact, I've checked the data. We cannot use the data for anything, unfortunately. So what we're going to make use of basically is the active data set, the one that we generated the source via hammering ourselves. So you had Traverse 1, Traverse 2, and Traverse 1. And for Traverse 1, you had about 4 spread. So what I will do is to take examples of this spread, and I will immediately start the presentation on how to carry out the analysis. So in carrying out the analysis, you go to your computer and open the icon surface wave analysis, this particular one. So irrespective of the size imager software that you downloaded, you should have the surface wave analysis module, wizard module. So this is what you open, and you choose active source 1D. So active source 1D, that's what we're choosing. Okay, so this is what we'll get. So when you get here, you just come to File, open Seg 2D, and we'll have to look for the name of our file. The name of our file for Traverse 1 is, the number is 023679. I can easily copy that, then see, I paste it here, open. So this is our first short gather. I'll come back also to determine the offset. The offset is -5, and we already know that the geophone interval is 1. So we have to change that. So the first thing you do upon loading your data set is to go to File. No, you go to File, you've opened your data set, which is this. Then you go to Edit. Then Edit Source and Receiver Location. So our group interval is 1. Our short coordinate is -5. So you have to click Set, then OK. So that's fine. You see your source will change to -5 and the geophone spacing remains. So once you do that, the next thing you can do is to play with your data set. So because you'll be giving a report, you might have to copy one of these seismograms here and paste in your report, like a sample seismograph that you get. And in doing so, this is what you get. So you look for the best data. You can see some noisy traces. So we have some noisy traces. It's either you remove them or you leave them like that. I think you can leave them like that. Okay. After that, you go to surface wave analysis and phase velocity frequency transform. So that's where we are now. If you click on that, you see your that's your phase velocity starts at 600. At 0, ends at 600 meters per second. Your frequency starts at 0, ends at 40. So you can play with these phase velocity final values or the end values, depending on the characteristics of the seismic velocity that you are getting. If it is it's a place that you're expecting high values of the velocity, you might have to increase this. Or if it is not, you can leave it. If you're expecting to get more information from the far end of the spectrum, you can increase your frequency. But most times 40 should be fine. Then I'll click OK. So this is very important. If you click OK at times, you will not see the dispersion curves. And this might be challenging because of something that happened. So in my own software, I'll come back again. So you have to click on surface, phase wave velocity, then advanced menu. So you notice that this is a forward shot. So in the direction in the previous one that's calculated that it was backward. So you have to change this to forward. Then okay. So if we do that, you would notice that we now have our phase. This is called a phase velocity spectrum. And in your phase velocity spectrum, you will now see what we call our dispersion curve. Our dispersion curve just tells us how the phase velocity changes with frequency. So this is phase velocity and this is frequency. The ideal, normally if you check textbooks, so this is how you should go. So this is your phase velocity, pH, and this is your frequency. So this is the same thing as this. So what this guy is the same thing as this guy, but this has been turned upside down. So this whole image for this software, they turned theirs upside down. So that's why if you turn this upside down, you are going to get something like this. See? So this is related to this guy. I hope that is clear. So now after getting your phase velocity spectrum, the next thing you need to do is to pick your what we call fundamental mode, your fundamental mode of vibration. So if you remember your physics, when we were talking about your FERC, you have different modes of vibration. So the same thing happens here. This wave has different modes of vibration. So what we're interested in is the fundamental mode. Then if you look at this, your data too, we have two sets of dispersion curve. You have this one here, and you have this one here. So the lowest one, let me use a different, you have this, and you have this. So the lowest one, that's this red part. This one is your fundamental mode. It's assumed to be your fundamental mode. Then this is higher mode. But there are different higher modes. It can be the first mode of vibration, second mode. But usually it is difficult to determine which of them is associated with the higher mode. So basically you just infer this as the higher mode, okay? So this is what we have. So the next thing we have to do now is to come to our data sets and pick phase velocity. So we pick phase velocity, okay. So it will automatically pick some for you, but it now behoves on you to carry out, to adjust the peaks. So we are picking the points with high amplitude. This high amplitude is given as the darker colors, okay? So high amplitude. So be careful not of what you pick. If you pick, there are different, this is where a challenge is. You can actually pick, if you pick like this, you are not wrong, but you are also not so correct, because this can be, this part from literature can be as a result of superimposition of modes. So as much as possible, you have to be very careful with your picks. So what I would like you to do is that once you finish picking for each of the array, for each of the shots, just let me see, so I know whether you have picked it correctly. Okay. Whether you have picked it correctly. So due to, will I say my experience, I won't go up like this, I'll go like this. It's more likely like this. So we have our first mode, fundamental mode picked. So once you finish picking it, you just come to show phase velocity curve 1D launch. So this is what we have. Okay. So we have something like this. The next you need to do is you don't need to smoothing. I don't usually smoothing. I'll just go straight to my initial model, and we have something like this. Then this is your initial model. After this is your initial model. In fact, this is your inversion model. So the other part is your phase velocity spectrum. So you want to convert that dispersion curve. That's this dispersion curve that we've picked. You can see it's now back to the normal one, that's the phase velocity and frequency. So you want to convert this dispersion curve to the shear wave velocity of the subsurface, and that is done via inversion. So that's why when you come here, you come to initial model. Your initial model is based on certain assumptions, and you get your initial model. Upon your initial model, you run your inversion. Usually an iteration of 5 is fine. Okay. You can see the RMS error is less than 5%. It's just about 5.725195 millimeters per second, which is fine. So this is our data set. So if you look at our data set, it shows us that the top surface has a relatively higher velocity. Okay, so we have higher velocity here. This is like one layer. This is for interpretation. This is like another layer. Then this is, it now increases with depth. So your cutoff can be let's say like 10.4. That's the depth to relatively competent area. So this you can improve upon depending on your peak. So I'll just continue now. Then the next thing you need to do is to, once you have gotten this, from this now you can estimate your, this will give you an average. The software gives you an average VS of 177.6 meter per second. So you have to write this down. You can do a lot of things with this. I can increase my view. Let's say 30 meters. So 30 meters is fine. Okay. So the shear wave velocity increases from about 160. I know if we pick very well, so if we change our peaks, so let's just save this one and go back here and change the peaks that we did. So you could see the difference. So let's assume that you pick like this. Okay, let's show 1D. So this is what we picked. So dispersion curve, initial model. Okay. Inversion. We could see our RMS error is starting at relatively higher values compared to the previous one also. Okay. So that's that. We reduce this just to have an idea. So at almost that 10.414, so you have it greater than 2.05. But you notice that the peaks of the top of the near surface isn't so correct. So that's why your peaks are very important. And the VS of the top 30 meter has increased to what? 201.9 meters. So those are the things you have to be very considerate about. But for your level, just go ahead and pick as we have picked originally. When you pick all that, you can now see how it would give you. Okay, so this is what we picked. Okay. So something like this was what we did the other time. Okay. I'll just show you, I'm just repeating it just for clarity. Be that as it may, in any scenario, your